We all think of the Mahabharata as one of the world's greatest stories, right? A foundational epic. But what if it's more than that? What if it's also a detailed historical diary, with its pages filled not just with poetry, but with incredibly precise astronomical observations? That's the rabbit hole we're going down today. Because hidden inside its 100,000 verses, there seems to be a cosmic clock, and scholars are using it to try and solve the epic's single greatest mystery.
So, let's just get right to it. The main question is simple to ask, but it is incredibly hard to answer. When did the armies of the Pandavas and Kauravas actually meet on that battlefield of Kurukshetra? And look, we're not talking about some vague long ago. We are hunting for a date. A year, a month, a specific day. This is basically a historical cold case, and we're about to look at all the evidence.
All right, so to crack this thing, we need a plan. First, we're going to look at the three main types of clues that scholars use. Then, we'll introduce the four main suspects. These are the four competing timelines that are out there. After that, we'll pit them against each other in a head-to-head showdown. And finally, we'll try to understand why, after all this work, the mystery is still unsolved. Let's get started.
Okay, to find our date, we've got to understand the tools of the trade. Historians don't just, throw a dart at a board. They follow very specific lines of evidence. And for the Mahabharata, there are really three main ways they try to piece together the past. And believe me, each one gives us a very different part of the puzzle.
So the first method is just good old-fashioned genealogy. Scholars look at texts like the Puranas, which list all the kings who ruled after the war, and they literally count the generations down to figures we know from recorded history. It's kind of like building a family tree backwards, but it's a bit shaky. The second method is archaeology. We're talking about digging in the dirt at places like Hastinapura and Dwarka. Archaeologists like B.B. Lal and S.R. Rao have found ancient pottery, even entire cities submerged underwater, that seem to line up with the epic. But the third method, that's the most precise and the most controversial: archaeoastronomy. This approach treats the Mahabharata like an accurate logbook of the sky. Using powerful software like NASA's planetary simulators, researchers can literally rewind the heavens to find the one single moment when the stars, the planets, and all the eclipses mentioned in the text align perfectly. It's like finding a celestial fingerprint.
So what happens when you use all these methods? Well, instead of one clear answer, you get four major competing theories. So let's think of them as the four prime suspects in our historical investigation. Each one is backed by brilliant researchers and piles of complex data, but they're separated by thousands of years.
And here they are. First up, we've got the 5561 BCE model, pushed by Nilesh Oak. He argues for this really deep antiquity based on a very rare observation of the stars Arundhati and Vishista. Then you have Ved Vyas's date of 3162 BCE, which is built on the internal logic of ancient Indian calendars. Next, there's Suraj Bala's 3139 BCE, which basically works backward from the traditional starting date of our current cosmic age, the Kali Yuga. And finally, you have 3067 BCE, a date championed by folks like BNHR, which hinges on finding a perfect computer-simulated match for a series of back-to-back eclipses that are described in the text. 4 dates, 4 methods. Let's see how they stack up.
Okay, this is where it gets really fun. To test these theories, we can't just talk in generalities. We need to zoom in on specific, dated events right from the Mahabharata narrative itself. We're going to take key moments and see which of these four timelines can actually match the date and the astronomical details from the text.
Right before the war, Krishna makes this one last, desperate diplomatic effort to stop the bloodshed. He travels to the Kaurava court to try and negotiate a peace. Now, the text is super specific about when this happened. It tells us the lunar month, it tells us the season, and it even tells us the star constellation, or nakshatra, that Krishna left under. This is our very first test.
So right away, just look at the sheer disagreement here. It's wild. The 5561 model says this happened in late August. The other three put it in late September or early October, but in totally different years. It's the same event, and we already have a 2,500-year gap between the proposed timelines. So how can that be? Well, the answer might just come down to how you translate a single ancient word.
And this just perfectly illustrates the problem. The text says Krishna traveled during the Hemanta season, which traditionally means early winter. Nilesh Oak, who backs the 5561 BCE date, points out that Achar's date of September 26, 3067 BCE is smack in the middle of autumn, or Sharad. He says that's a direct contradiction of the text. But Atra's team fires back that their translation of the lunar month Kamude actually points to autumn. So get this. The entire 2,500-year difference can literally hang on whether you translate an ancient season as autumn or as winter. All right, so diplomacy failed. The armies are gathered on the field. Let's move to the single most important date in the entire epic, the day the war actually began. You'd think this, of all things, would be crystal clear, but nope. The disagreement here is just as fierce. I mean, just look at this. 4 different scholars, 4 totally different start dates. You've got a cluster there in mid to late October for 3 of the models, but the 3067 BCE model puts it way later, on November 22nd. Now, the core of this whole debate isn't just the date itself, but the phase of the moon. Oak, Arya, and Bala are all convinced the text says the war began on a new moon, an Amavasya. Ashar, on the other hand, says it started just before a full moon, and that single detail has massive, massive consequences, as you're about to see. 10 days into this brutal war, we get a huge moment. Bhishma, the Grand Patriarch, the supreme commander of the Kaurava army, is finally brought down. He's pierced by so many arrows, he can't even touch the ground. He falls, but he doesn't die. You see, he has this boon where he can choose the moment of his own death, and he decides to wait for a more auspicious time.
So this event gives us 2 more very precise dates to compare. According to the 5561 model, Bhishma falls on October 25th. For the 3139 model, it's October 23rd. This is the moment his long wait begins, suspended on that famous bed of arrows, waiting for the sun itself to change its course in the sky. And that wait, well, that's going to be our ultimate test.
Now we get to a piece of evidence that is like a forensic smoking gun. On the 14th day of the war, the battle rages on long after sunset, deep into the pitch-black night. And the text is incredibly specific here. It says the fighting happened in total darkness until the moon finally rose very, very late, around 2 o'clock in the morning. This is a hard, observable astronomical fact that any valid timeline has to be able to replicate.
And this is where that whole debate about the moon phase comes back in a big way. See, if the war started on a new moon, like Oak, Bala, and Arya claim, then 14 nights later you would have a waning moon that rises very late, which, ding ding ding, perfectly matches that 2 a.m. observation. But if the war started just before a full moon, like Akar's 3067 model proposes, then the 14th night would be a brilliant, bright full moon, which would have been high in the sky all night long. A 2 a.m. moonrise is literally astronomically impossible on a full moon night. The bottom line is, this one little verse seems to put a huge dent in the 3067 BCE timeline.
So, after the 18-day war is over, the victorious Pandavas go to Bhishma, still on his bed of arrows. He gives them his final wisdom, and then he waits. He's waiting for the winter solstice, the day the sun begins its northern journey, which is known as Uttarayana. The text says he died on that exact day. This is our final and maybe our most important anchor point.
Now, the really interesting thing here is the duration of his wait. The text is a little bit ambiguous. It mentions 58 nights, but also implies a longer period. And this leads to this huge disagreement. Saroj Bala calculates he waited exactly 58 days, dying on December 20th, 3139 BCE. But Nilesh Aduk and Ved Vyasa argue that the 58 days refers to something else entirely, and they calculate a much longer wait of over 90 days. Achar's model gives 2 possible dates in mid-January 3066 BCE. The ability to perfectly align the day Bhishma fell with the exact date of the winter solstice is really the ultimate stress test for all of these models.
So, we've seen how the dates of the events themselves shift around. But one of the most surprising outcomes of this whole debate is something way more personal. How old were Krishna, Arjuna, and the others when they actually fought this war? The answer completely depends on which timeline you subscribe to. And this just brilliantly shows the massive gap between the theories. In Achar's 3067 BCE model, Krishna and Arjuna are 45 years old. They're veteran warriors, right in their prime. That feels pretty reasonable. But in Arya's 3162 BCE model, they're pushing 60. And then in Nilesh Oak's 5561 BCE model, they are a staggering 72 years old when the war starts. This really forces us to ask a tough question that goes way beyond astronomy. Did people in that ancient era just live a lot longer, or are some of these very ancient dates stretching the limits of what's biologically credible? Okay, so after looking at all this conflicting evidence, the star charts, the moon phases, the arguments over seasons, you might just be wondering, why don't we have a single, clear answer? Why, after decades of research with supercomputers, is this case still unsolved?
Well, it really boils down to four main problems. First, as we saw with that whole winter versus autumn thing, the translation of ancient Sanskrit is incredibly difficult and highly contested. Second, that traditional 3102 BCE start date for the Kali Yuga, well, it might not be an actual observed memory. It might be a date that was mathematically back-calculated centuries later by astronomers like Aryabhata, which would make it a totally artificial anchor point. Third, the archaeology is a huge issue. The pottery found at Mahabharata sites is consistently dated much, much later, around 1200 BCE, which creates this massive conflict with the astronomical dates. And finally, that just means the clues from the sky don't match the clues from the Earth, leaving us with this absolutely fascinating but still unresolved puzzle.
In the end, this whole quest to date the Mahabharata is so much more than just a search for a number. Like this quote says, it's really an attempt to reverse engineer an entire lost world, using every tiny fragment we have left, the memories of the stars they watched, the pottery they drank from, and even the ruins of their sunken cities lying at the bottom of the ocean.
And that really brings us to our final thought. We've spent all this time chasing an exact date, trying to pin it down in history. But maybe the most important question isn't just about when it happened. Maybe it's this. Does a story that has guided billions of people for millennia really need a precise calendar entry to hold a truth that is, and always has been, completely timeless? Thank you so much for joining us on this investigation. If you appreciate this kind of deep dive, please be sure to like this explainer, subscribe to our channel Shastra, and share it with anyone else who loves trying to crack these ancient codes. It genuinely helps us bring more of this content to you.